All right, welcome back, guys. We're going to be jumping into 4.5 today. Now, you might be going, well, hold up, we were just in 4.1. How are we already in 4.5? Well, 4.1 was good. We introduced probability and we talked about ratios and proportions. Sorry, we're talking about probability today. 4.2, though, you will cover in geometry. In 4.3 and 4.4, we cut for the interest of time since the school year is kind of squished. If you do want to check those out on your own, feel free. You can let me know any questions you may have about them. But for now, we're going to jump into 4.5. So 4.5 is all about probability. 4.5 is all about probability. So to get the ball rolling, let's talk. What is the probability of rolling any of these things with a single-sided die? Go ahead and pause the video and see if you can figure it out. Okay, so you've had a second to write it down, think what you think. Let's go ahead and come up with the answer. So what's the probability of rolling an even number? Well, on a die, there's 6 sides. 3 of those numbers are even, so it is 3 out of 6, or a 1 in 2 chance. Well, there's only 1 6 on a fair die, so there's a 1 in 6 chance of getting a 6. A number larger than 2. Well, there are 4 numbers larger than 2 on a 6-sided die. So 4 out of 6, which is the same as 2/3. Not a 5. That'd be a 5 in 6 chance. And not a 5 or a 4. Again, there are 4 other numbers, so that'd be a 4 and 6 chance. Again, this is going to be all about probability. So let's get into what are some definitions of probability. Okay, we've got the ball rolling. Well, probability is the likelihood an event occurs. The likelihood an event occurs. These numbers I wrote down up here are the likelihood, the chances. I could turn them into percentages, which we often hear in probability. The percent chance a certain outcome occurs. Now, there are 2 types of probability. Again, if that went too fast, feel free to go back, pause the video on the definition, because I do want you writing these down. Experimental probability. This is what actually happens. Okay? What actually happens. And that's going to be how often something occurs divided by the number of possible outcomes. This would be if I rolled a die 7 times and I counted how many 4s I got or how many even numbers I got. However many even numbers I got divided by how many times I rolled the die. Theoretical probability is what we think will happen. That is the number of favorable outcomes divided by the number of possible outcomes. If we look at the example above, this was theoretical probability. We didn't take out a die and achieve these numbers. We didn't roll the die 6 times and get 3 even numbers. No, we thought about it theoretically. Okay? The number of favorable outcomes divided by the number of possible. If I'm looking for an even number, the favorable outcome is a 2, a 4, or a 6, whereas the possible outcomes, there are 6 different numbers, hence you get 3 over 6. Think about it for the number 6. The favorable outcome is rolling a 6. That could happen one way. And there are 6 possible outcomes, thus 1 over 6. Again, experimental probability is if we used a simulated die roller on the internet, or we physically rolled a die, 7 times. The amount of times you rolled the die would be on the bottom, and the amount of times you achieved the number you were looking for would be on the top. Again, experimental versus theoretical probability. Please write those down. What is the sample space? Well, the sample space is the fancy word you might hear us use in probability for all the possible outcomes. Or the sample space of all the possible outcomes, that would be, for rolling a die, the sample space. 1, 2, 3, 4, 5, 6. So, let's practice. Come up with the theoretical probability of the following events. Go ahead and pause the video and give it a shot. Okay, now that you've unpaused it and tried it, let's see what you came up with. What's the theoretical probability of flipping a coin? Well, the sample space of flipping a coin, or all the possible outcomes, there are only 2. You can get heads or tails. Okay? If I wanted to get heads, that would be 1 out of 2. Picking a certain card out of a deck. Let's say I'm looking for the Queen of Spades. Well, the sample space is 52 cards, and I'm looking for the Queen of Spades. So it would be 1 out of 52. If I was looking for just any heart, that would be 13 out of 52, because there are 13 hearts in the deck. Guessing right on a multiple choice problem. Well, the sample space is how many options there are. If it's A, B, C, D, then there would be 4 options. And there's going to be 1 right answer, so it would be 1 out of 4. Okay? Hopefully you got those right. If not, at least I hope these make sense. Let me know if they do not. Next topic we're going to jump into, do the theoretical and experimental probabilities always match? Let's say I go to flip a coin. And we know the theoretical probability is 50%. And I flip it 4 times, and I get 4 heads. Does that mean probability is wrong? Well, not quite. You see, we come up with theoretical probability largely based on this idea of the law of large numbers. The law of large numbers says the more often an event is tested, the closer it is to the theoretical probability. The more often an event is tested, the closer it is or will be to the theoretical probability. What does this mean? Well, if I flip that coin 4 times, and I get 4 heads, you go, man, the theoretical probability is 50%, but you got 100%. That's weird. Well, what happens is if I flip that coin 100 times, maybe then it's 60 heads and 40 tails. I flip it 1,000 times, and it's 550 heads and 450 tails. Maybe I flip it 1,000,000 times, and it's 501,000 heads and 499,000 tails. Okay? The point I'm getting at here is the more you test an event or the more you run an experimental probability, the closer it will get to the theoretical probability. That is the law of large numbers. It's why we don't freak out when we flip a coin 4 times and get 4 heads and go, oh my gosh, probability's a lie. No. That's just a very small sample size. If you do a large sample size, the law of large numbers will kick in. The more samples you do, the more likely the experimental probability will match the theoretical probability. Okay? If there is a 40% chance of rain, what is the probability it does not rain? I want you to think about that while I change the slide. You probably have come up with the answer of 60% at this point, right? There's a 40% chance it rains. There's a 60% chance it doesn't. This is called the complement. The complement is the probability something does not happen. I do want you to write this down. We find this subconsciously by subtracting the probability something does happen from 1. You subconsciously said, well, if there's a 40% chance it rains and there's a 100% chance together of it raining and not raining, 100 minus 40 is 60, therefore there's a 60% chance it doesn't rain. You calculated the complement in your head. It's the probability something doesn't happen. And again, the probability of something happening and its complement should always add up to 1 or 100%. Okay, so let's do an example. Mr. Carter's Apple store was quality control inspected by Apple headquarters. Out of the 1,000 iPhones in the store, 4 were defective. What is the experimental probability of an iPhone in Mr. Carter's store being defective? Okay. Out of the 1,000 iPhones in my store, 4 were defective. What is the experimental probability of an iPhone being defective. Okay? What I want you to do is to go ahead and try this problem on your own. See if you can figure it out. Okay, so now we figured it out. You've taken time and gotten through it. We're going to come up with the experimental probability. Okay, well, it's the number of favorable outcomes versus the total amount of outcomes, total amount of possibilities. So if I'm quality control inspected and 1,000 iPhones are in my store and they find 4 to be defective, what I hope you came up with is 4 over 1,000 is the probability of an iPhone being defective. Again, experimental probability is the frequency divided by the number of possible outcomes. Okay, how many were defective based on versus how many total are there? So there's a 4 out of 1,000. Maybe you wrote it as a decimal, or roughly 0.4%. Okay, probably nothing new to you, nothing crazy. Let's continue. Let's say, continuing in Mr. Carter's Apple store, there is a 95% chance MacBooks are working normally. And Mr. Carter has 452 in his store. How many are going to most likely be defective? There's a 95% chance MacBooks are working normally, and Mr. Carter has 452 in his store. How many are defective? Okay, pause the video. Try and figure it out. Okay, so hopefully you've given it an attempt, and you're going to try and figure it out. What you saw in the last problem that we did is what? We did the number of favorable outcomes divided by all the potential outcomes, and what that gave us was the percent likelihood that something was defective. Now we got a little bit of different info here. We got the 0.95 or the 95% chance, and we know there are 452 in the store, but we don't know how many of those are defective or what the likelihood is, or how many are defective. Okay, so I'm going to multiply 452 by both sides to get my variable alone. And when I do that, I get 0.95 times 452, which gives me 429.4. Okay, 429.4. But is that 429.4? That's how many are defective? Well, no, it's not, right? That's how many are, the 95% is the chance they're working normally, which means 429.4 are most likely working normally. If we round down, since you can't have 0.4 of a laptop, 429 are the amount of defective. How do I figure this out? Use the complement. This is how if there's a 95% chance that a laptop's working normally, and there are 452 in the store, and we use that logic to figure out that 429 are most likely working normally, then we can do 452 minus 429, and that will give us the amount that most likely are defective. So when I do that, I get 23, and that will be the number of laptops that are most likely defective. Okay? Again, 4.5, all about probability. I hope this makes sense. A lot of it's probably review. If you're confused on any of it, shoot me an email, let me know, and have a great day.